Hi, I'm Ryan Baker, and this is Big Data in Education 10th Anniversary Edition. It's great to see all of you, and great to have all of you see me. I can't believe that this course has been going for 10 years, and you'll see little snippets of me from different eras across the weeks of this course, and you can decide how badly I've aged. But it's great to see you all. Welcome to Big Data in Education. In this first video, we're going to discuss what educational data mining is. We'll introduce you to it, and we'll talk about what tools we'll be using in the class. So, in this MOOC, or online textbook, you'll learn about methods used for exploring big data in education. So, there have been two communities that have been involved in a very key way in the development of this community. The International Educational Data Mining Society, which had its first event, a workshop in 2005, its first conference in 2008, and we've been publishing the Journal of Educational Data Mining since 2009. The other being the Society for Learning Analytics Research. It had its first conference in 2011 and then founded the Journal of Learning Analytics in 2012. These two communities have the joint goal of exploring the big data now available on learners and learning to promote, among other things, new scientific discoveries and advance the learning sciences, to better assess learners along multiple dimensions, and to provide better real-time support for learners, including adaptive learning systems and actionable information for teachers and other people working in schools. This course is about the key problems, methods, and open questions in the field. And you'll learn both classic methods and emerging methods, and some of those emerging methods are emerging pretty fast. This course is now in its 7th edition, which I'm calling the 10th Anniversary Edition. It's been amazing to watch all the changes that have happened in these years, and it's been a great privilege to have had the opportunity to have been part of a few of them. And to be honest, the hardest part has been keeping this course close to current when things are moving so fast. Where do these methods come from? Some of the methods that we're going to talk about in this class will be familiar to somebody with a background in data mining and machine learning. And some of the methods would be familiar to someone with a background in psychometrics or traditional statistics. But you don't have to have either of these backgrounds to get something out of the course. Pick and choose what you find most useful. Over the years, the students who've gotten the most out of the course are not the ones who just watch video in sequence, but the ones who focus in on what they find most useful. So this course is named Big Data in Education. And one very reasonable question is, what makes data big? And one answer to that is Laney's 3 V's. Volume, how much total data. Velocity, how fast is the data coming in and how fast do you have to handle it. And variety, incompatible formats, non-aligned data structures, and inconsistent data semantics. Now, lots of folks want to tell you what the 4th or 5th or 6th or even 7th V should be in order to get you to cite them instead of Laney. And they make up all kinds of stuff like veracity, value, variability, visualization, validity, velociraptors, and honestly, I really like the original 3 V's. I don't particularly see why visualization is any more an aspect of big data than velociraptors are. Is educational data big? Well, no. It's not, right? Like the PSLC Data Shop, which is the largest public open repository, is the tiniest of pebbles compared to the mountain that is Google. And that difference gets bigger all the time, even as educational data keeps getting bigger. But hey, at the same time, the name of this course is Big Data Education, thanks to someone in marketing in 2013. And big data in education is big. It's big by comparison to most classical education research. It's big compared to data sets in many domains. It's just not Human Genome Project or Google big. It's big enough that trivial little differences in metrics, like an R-square of 0.0019, routinely come up as statistically significant. And later in the semester, we'll talk about why this is truly a trivial difference. And incidentally, I'm going to talk about statistical significance sometimes, particularly when we get to correlation mining, but it's not going to be a focus of the class because statistical significance really is about figuring out what's true of small data, and we are interested in much bigger data. Also, people trained in statistics, please note, terminology is sometimes conflicting between stats and data mining machine learning. Sometimes it's what Reshley and colleagues call a jingle jangle. Sometimes the same word is used to mean different things, and sometimes different words are used to mean the same thing. And across this course, I'll highlight particularly annoying cases where this emerges. There's a lot of types of educational data mining, learning analytics methods, and we're going to talk about a lot across the course of this course. Some big categories involve prediction, structure discovery, relationship mining, visualization, and discovery with models. In prediction, we develop a model which can infer a single aspect of the data, which we call the predicted variable. You'll also sometimes see dependent variable or target variable, from some combination of other aspects of the data, the predictor variables, which you'll sometimes see called independent variables or features. So you might ask questions like, can we predict which students are off task? Or can we predict which students will fail the class? In structure discovery, we try to find structure and patterns in the data that emerge quote-unquote naturally, with no specific target, no specific variable we're trying to predict, and no specific research question necessarily in mind. In relationship mining, we look at discovering relationships between variables in a data set that has a lot of variables. And the types of relationship mining basically vary in terms of what kind of relationships we're looking at, from correlations to sequential relationships. In discovery with models, a pre-existing model developed with EDM prediction methods or clustering or knowledge engineering or whatever is applied to data and uses a component in another analysis. And this is one of the places where you see the difference between applied data analysis in specific fields and more kind of core traditional machine learning data science. Because discovery with models is something that pops up pretty much every time you see an applied intersection of data science with a specific discipline. So some closing thoughts on this first video. Educational data mining and learning analytics methods are emerging for big data in education. There's a lot that have now been around for over a decade, but there's also things that are just continually emerging as we go, as data science itself moves forward so quickly. In this class, you'll learn the key methods and how to use them for goals like promoting scientific discovery and driving intervention and improvements in educational software and systems. We'll discuss the strengths and weaknesses of these methods for different applications, so important to use the right tool for the job, and we'll discuss how to determine if your analysis or modeling is trustworthy and if it's applicable. Thank you very much, and I'll see you in the next video.